All right, today we're jumping into one of the most fundamental skills you'll ever need when you're working with data: how to find the exact piece of information you're looking for using SQL filtering. You know the feeling, right? You're staring at a database with just millions, maybe even billions of rows of data. Trying to find that one specific thing you need can feel completely overwhelming, kind of like searching for a needle in a giant digital haystack. Well, what if you had a super powerful guide to navigate that chaos? That, my friends, is exactly what SQL filtering is. It's the tool that lets you slice right through all the noise, ignore all the stuff you don't care about, and pull out only the precise data that you need. It's clean, it's efficient, and it's incredibly powerful. So here's how we're going to break it down. First, we'll talk about why we even bother filtering. Then, we'll get into the most important tool, the WHERE clause. After that, we'll level up with smart comparisons and combining conditions. And finally, we'll look at some real-world examples and wrap it all up with your new filtering toolkit. Okay, let's start with the big picture. Why is filtering so critical? Well, honestly, think about it. Nobody ever wants to see an entire database table. You're almost always trying to answer a very specific question, and that means you only want a specific chunk of that data. And believe me, you see this in action constantly, every single day. You know, when an online store shows you just the orders you placed this month, that's filtering. When a school system generates a list of students on the honor roll, that's filtering. Even when you go online shopping and search for products under, say, $50, yep, you're using a filter. So how do we actually pull this off in SQL? It's time to meet the most important, most fundamental tool in our entire filtering kit, the WHERE clause. The WHERE clause is really the heart and soul of filtering. You put it right after your table name in a query, and it basically acts like a bouncer at a club. It checks every single row, and it only lets in the ones that match the specific criteria you've put on the list. And here's a super simple way to think about it. If you have ever used the filter function in Excel or Google Sheets to hide some rows and show others, then you already get the basic idea of a WHERE clause. It's the exact same concept, just written out in code.
To really see how this works, we're going to use the simple expenses table for all our examples. It's got an ID, a category, an amount, and the month for each expense. Nice and easy.
Okay, here's our very first query. We're telling the database, hey, select all the columns, that's what the little star means, from our expenses table. But then, here comes the magic part, where the category is equal to food. And the result is, well, it's exactly what you'd hope for. The database looks through the whole table, but only gives you back the rows that are labeled food. Everything else, housing, transport, you name it, gets left behind. Now, checking for a perfect match like food is awesome, but what if we want to ask more complex questions, especially when we're dealing with numbers? Well, for that, we need something called comparison operators. Let's check them out. Here are the main ones. You've definitely seen these before in math class. You've got your standard equal to, but also greater than, less than, and versions that include or equal to. And the really useful one here is not equal to, for when you want to specifically exclude something. Let's give one a try. This time, our query is looking at a number. We're telling the database to show us everything from the expenses table, but only where the amount is greater than 100. So, what do we get back? Well, we won't see an expense for $50 or even one for exactly $100. The result will only include those big expenses that are strictly more than $100. See, this is how we start to make our questions way more precise.
But what if a single condition isn't enough? What if the question we're asking has 2 or even 3 parts? This is where our final set of core tools, the logical operators, come in to save the day.
The 3 big ones you need to know are and, or, and not. And is the strict one. It means both conditions have to be true. Or is way more flexible. It just needs one or the other to be true. And not is what you use when you want to find everything except for a certain condition. Let's look at how and works by combining 2 rules. Here we're asking for expenses where the amount is greater than 50 and the month is June. A row has to pass both of these tests to make it into our final result. This is how you really start to zero in on your data. An expense of $60 in May? Nope, that's not going to show up. An expense of $30 in June? That won't show up either. Only the records that pass both tests, over $50 and in the month of June, are going to be returned. Okay, so we've got the tools down. Now let's see how this stuff actually gets used out there in the real world, both for you personally and for huge companies. What's so cool about filtering is that it scales up perfectly. You can use these exact same ideas to manage your own monthly budget or to analyze millions of sales transactions for a giant global company. The logic behind it is exactly the same.
So for a personal example, let's say you want to review how you spent your money at the beginning of the year. With a super simple filter for the month of January, you can instantly get a list of just those expenses. It's a really quick way to get a clear picture of your finances.
Now let's scale that up. A big e-commerce company might run a query to find all of its high-value orders, maybe everything over $500. This isn't just random data, it's business intelligence. They can take that list and use it to identify their VIP customers, maybe for a special marketing offer. We have definitely covered a lot of ground, so let's pull everything we've learned together into one simple, final toolkit. This right here sums up the core of SQL filtering. You've got the where clause to kick things off. You've got comparison operators like greater than to check values, and you've got logical operators like and or to combine multiple rules into one. That's it. That's the whole foundation.
So just remember this, filtering isn't only about finding data. It's about being efficient and getting to the meaning. By asking the database for only what you need, you're not just getting clearer answers, you're actually making the database do less work. And when you're dealing with massive data sets, that means your queries run so much faster, and the results are immediately useful.
You now have the fundamental tools to ask incredibly specific, powerful questions of pretty much any data set you can find. The only real limit is your own curiosity. So, the real question is, what are you going to go out and discover?